Alright, welcome to our lesson today on rational and negative exponents. Alright, so in today's lesson, I guess pretty straightforward with how does this title suggest. We'll understand how to deal with exponents that are fractions and negatives and both at the same time. Okay, it looks very cursed, but trust me, it's going to be okay. Alright, so before we do anything, we'll quickly review the exponent laws here. Right, or I guess one of the exponent laws. So if we have the same base and we're multiplying it together, when it comes to the exponents, we just add them up. Right? So if we have something like a to the power of m, so let's do some number examples. If we have, let's say, 2 to the power of 3 multiplied by the 2 to the power of 2. Right? So obviously, we could just calculate it as 8 times 4 to get 32. Or we can just add the exponents up together. Right? So instead of calculating in raw, we can just do 2 to the power of 3 plus 2, which is 2 to the power of 5, which is 32. Right, so that's all it is telling us. And this only works if they're the same base. So in this case, if we have fractions, so if we have 4 to the power of 1/2, right, we notice that when we multiply them together, right, we get 4 to the power of 1 over 2 plus 1 over 2. We just get 4 to the power of 1, which is 4. And similarly, if we have 4 to the power of 1 over 3 multiplied 3 times, right, we just add it up again. So 4 to the power of 1 over 3 plus 1 over 3 plus 1 over 3 is still 4 to the power of 1, which is just 4. Right? So we notice that what the fraction exponents are is just square roots. Right? So the only reason, or the only way we can actually get 4 here is if the fraction exponents just mean square roots. Because if we multiply the square root of 4 by the square root of 4, we just get 4 by itself. Right? The square root of 4 is 2. So 2 times 2 gets us 4. So similarly, with the 1 over 3, it's the cube root. Okay? So if we have the cube root of 4 multiplied by itself 3 times, we get 4 once again. Right? So fractional exponents are just a fancier way of writing square roots. And now using the same exponent law, we can actually figure out how negative exponents work as well. Right? If we get 4 to the power of 1 over, if we have 4 to the power of negative 2 times 4 to the power of positive 2, we're just adding them up. So negative 2 plus 2 just gets us 4 to the power of 0. And just like any number, anything to the power of 0 is just 1. Alright, so this tells us something. So some number here multiplied by 4 over 2 will get us a 1. And the only way we can get that is if it was a fraction. Right? It will be 1 over 4 over 2. And in that case, you can cancel them out to get a 1. Right? So what a negative exponent is we're just flipping it upside down. Right? This is the reciprocal. So this is a key word. Right? So reciprocal. Did I spell that wrong? No, I didn't. Okay, cool. The reciprocal of a number is the number that it will need to multiply to get 1. Or in other words, we just flip it upside down. Right? So if we just have a 4 by itself, or 4 squared by itself, we flip it upside down to get 1 over 4 squared. Right? So let's put all those into practice so far. So we have a bunch of different ones. So we'll take the first 6 as examples here. So 16 to the power of 1 over 2. So we found earlier that a fraction is just a square root. And the denominator of a fraction, right here, that tells us the degree of the square root, right? Or the index of the square root. So in this case, with 16 to the power of 1 over 2, all it is the square root of 16. And of course, with convention, because it's a square root, we don't really write the 2, right? If we just see a square root symbol, we'll just assume it's the square root. Right? So what number multiplied by itself twice gets us 16? Well, it's 4. Right? So 16 to the power of 1 over 2 is just the square root of 16, so 4. Okay, so now how about negative 64 to the power of 1 over 3? So once again, this is a fancy way of writing the cube root of negative 64. Okay, so that's pretty much all it is. So what's a number that I can multiply 3 times by itself to get negative 64? We got negative 4. So yeah, so far so good. Okay, so now here's something interesting. How about decimals? Right, so it feels like it keeps getting worse and worse. But all a decimal is a fraction. Right? So to convert 0.5 into a fraction, right? So we have 5 in the 10th place of the decimal. So it's 5 over 10. Right? So when we reduce it, we get 1 over 2. So if we have a number multiplied to the power of 0.5, all we are saying is just square root that number. Right? That's all it is. So the square root of 16 over 81 will just be 4 over 9. Right? So square root of 16 is 4, square root of 81 is 9. Okay, so that's pretty much the fraction exponents. And now with the negatives, we have 7 to the power of negative 2. So this is the same thing as saying 1 over 7 to the power of positive 2, which is just 1 over 49. All right, that's pretty much it. All we're doing here is squaring this thing and then flipping it upside down. Okay, so now here's something interesting. We have a negative 3 with a fraction. So all we are doing here, once again, we'll flip everything upside down. That's what the negative is. So what we end up doing here is we have 4 over 3 to the power positive 3. Right? So all this negative sign did was essentially we just flip the fraction around. Right? That's a reciprocal. 3 over 4 times 4 over 3 gets us 1. So that's why we flip it upside down. And from there, it's just as a quick arithmetic. So 4 to the power of 3 is 4 times 4 times 4, which is 64. 3 to the power of 3 is 27. And remember, it is a negative sign here because it is an odd power. Right? We have negative 1 times negative 1 is positive 1. Positive 1 times negative 1 gets back to negative 1. Okay, so combining everything we've learned so far, well, how about 81 to the power of negative 0.25? So the first step is always to convert it into a fraction when we see a decimal. So 0.25, that's a quarter. So it is 1 over 4, or negative 1 over 4 in this case. Okay, next, we get rid of the negative sign. So we have 1 over 81 to the power of 1 over 4. And now to calculate the fraction exponent, because it's 1 over 4, we have 4 as the denominator. All it is the 4th root of 81. So 1 over the 4th root of 81. So what number multiplied by itself 4 times gets to 81? Well, we have 3. So 1 over 3. Alright, so again, it looks complicated. 81 to the power of negative 0.25. What is that? Well, it's just 1 over 3. Right? So again, it's not too bad. So now, the last step to making everything more complicated is to look at this exponent law, where it's a to the power of m, all of this to the power of n. So all we do here now is just multiply the exponents together. So what we end up having here is, let's take 4 to the power of 3 over 2. So all we're doing here now is saying, 4 to the power of 3 over 2, all it is 4 to the power of 1 over 2 to the power of 3. Right? That's all it is, because again, exponents, when we take the exponent of an exponent, we just multiply the exponents together. Which means that we have 4 to the power of a half to the power of 3. And we know that 4 to the power of a half is just square root of 4 to the power of 3, which is just 2 to the power of 3, getting us 8. Right? So once again, it looks pretty complicated, but luckily it wasn't super difficult. Right? So all it is you split up the fraction and then do it separately. So now similarly, we can actually do another way too. If you're feeling more adventurous, again, this method is generally a bit harder, but it still works. Right? So instead of splitting it as 4 to the power of a half to the power of 3, we can also do 4 to the power of 3 to the power of a half. Right? And that gets us 4 cubed is 64. 64 to the power of 1 over 2, which means the square root of 64, which also gets us 8. So this means that with fractions, right, if we get a fraction exponent, the bottom half of the fraction, the denominator, tells us the root number, right? So the index of the root, how much of a root are we taking? And the top number, the numerator, is just a regular exponent. So we can take the root of the number and then take it to the exponent of the numerator right here. Okay, so let's do another few examples. 16 to the power of 1.5. Right? So as usual, we convert everything to a fraction. So 1.5 as a fraction would just be 1.5. So 1.5, which means 16 is to the power of 3 over 2. Right? So what we can do here is split that into 1 over 2 to the power of 3. And 16 to the power of 1 over 2 is the square root of 16, getting us 4 to the power of 3, which is 64. Right? So with a fractional exponent, it's a lot of splitting up and putting it back up again. So negative 636. Okay, next one, negative 32 to the power of 0.4. Once again, we convert that into a fraction, which is 4 over 10 reduced down to 2 over 5. And from here, we can split it up into negative 32 to the power of 1 over 5 squared. Okay? Which means that we're working with the fifth root of negative 32 of that squared. Right? Which is negative 2 squared. Right? Because negative 2 to the power of 5 is negative 32. And negative 2 squared is 4. We get rid of the negative sign because it's negative times a negative number. Right? And yeah, that's pretty much it. Of course, like I said, if you're feeling adventurous, you're more than welcome to try negative 32 squared or negative 32 squared, all of that to the fifth root. So you have something like the fifth root of whatever negative 32 squared is. Again, that's an option that will still get you 4, but it's a very, very big number I have to work with. Okay, so that's why I always recommend doing the root first, or the denominator first. Okay, let's combine more stuff together. How about a negative exponent with a fraction? So, a to the power of negative 2 over 3. Alright, so what we can do here is to get rid of the negative sign first in the exponent. So we do that by flipping the thing over, which becomes 1 over 8 to the power 2 over 3, which then becomes 1 over 8 to the power of a third squared. Right? Because all we're doing here is taking this 2 out. We know that 8 to the power of 1 over 3 is just a cube root of 8. All of that squared. That cube root of 8 is 2. So it's 1 over 2 squared. And at the end, we get 1 over 4. Right? So 8 to the power of negative 2 over 3 is just 1 over 4. Okay, let's do another one. 25 over 36 to the power of negative 1.5, which is the negative 1.5. As an improper fraction, we get negative 3 over 2. Okay, so let's get rid of the negative sign first by flipping the fraction upside down. So 25 over 36 becomes 36 over 25 to the power of 3 over 2. Alright, we can split that now into 1 over 2. That's the denominator times to the power of the numerator, which is 3. Okay, this gets us a square root of 36 times, or over 25, all of that to the power of 3. Square root of 36 is 6, square root of 25 is 5, 6 over 5 to the power of 3, we get 216 over 125. Right, voila, there it is. Right, so in a nutshell, all we're doing here is, if we see a negative sign, we just flip it upside down. So from 7 to the power of negative 2, it's just 1 over 7 to the power of 2. And with the fractions, we can think of it as taking the bottom number, so the denominator, that becomes the root number. So if 2 is the denominator, then the square root. If 3 is the denominator, then it's a cube root. And in the top part, the numerator becomes the general power of the entire question. So with that being said, here are the practice questions. So pause the video here, do them yourself, and we'll go over them in a bit. Okay, hope you have some time to work on those problems. Okay, so let's begin here. 0.09 to the power of 1 over 2. So anything to the power of 1 over 2 is just saying square root. Okay, so we're working with the square root of 0.09, which is 0.3. Okay, next, 27 to the power of negative 1 over 3. Okay, so we can get rid of the negative sign by flipping into a fraction. So 27 becomes 1 over 27 to the power of 1 over 3. And with 1 over 3, it is the cube root, because 3 is the denominator. The cube root of 27 is just 3. All right, next. Negative 27 to the power of 2 over 3. Right, so starting with negative 27, we have that to the power of 1 over 3. And we have the entire thing to the power of 2. Which means we're trying to find the cube root of negative 27. And we'll be screwing the final answer. And the cube root of negative 27, as we found earlier, is just 3, or negative 3 now in this case. We square that, getting us a 9. Okay, next. 4 over 25 to the power of 3 over 2. Okay, so very similar logic. So 4 over 25, we have that to the power of 1 over 2, and all of that to the power of 3. So to power of 1 over 2 is just a square root, so we have the square root of 4 over 25, getting us 2 over 5 to the power of 3, giving us the final answer of 8 over 125. Right, just like that. Next, we have negatives and exponents. So we will flip it upside down first to have 27 to the power of 4 over 3, which gets us 27 to the power of a third of that to the power of 4. This is just the cube root of 27 to the power of 4, getting us 1 over 3 to the power of 4, which is 1 over 81. Next, we got a negative decimal here, so just convert it. 16 to the power of negative 1.5, so 3 over 2. Which means we have 1 over 16 to the power of 3 over 2, which is 1 over square root of 16, which is 1 over 16 to the power of 1/2 to the power of 3, which is 1 over the square root of 16 to the power of 3, which is 1 over 4 cubed. And finally, that gets us 1 over 64. Not over 4, right? So we got a negative exponent, so we can flip it to get 4 over 9 over to the power of 5 over 2. We can split that exponent into 1 over 2 and power 5, getting us the square root of 4 over 9 to the power of 5, which is 2 over 3 to the power of 5, which is 32 over 243. All right, last one. Decimal, negative, conversion. So 0.04 to the power of negative 1.5, so 3 over 2. We can flip it upside down to get 0.04 to the power of 3 over 2, which is just 1 over 0.04 to the power 1 over 2 to the power of 3, which is that square rooted to the power of 3, which is 0.2 to the power of 3, which is, oh, no need to go back anymore, 1 over 0. Let's see, how many decimals do we have? We have 8, so 1, 2, 3, like that. All right, well, there we go. A bunch of practice, a bunch of scenarios. Again, the final boss of this chapter is pretty much a negative fraction, right? Or negative decimal. Yeah, but that's all there is to it. So keep practicing and stay hydrated.